These are exciting times. The messenger probe has swooped past Mercury and sent us back pictures of the areas we've never seen before in any detail at all. So first of all, a brief rundown on Mercury. It's the smallest planet in the solar system, diameter just over 3,000 miles, a bit bigger than the Moon. It's only 36 million miles from the Sun, and therefore in the sky it always seems close to the Sun, never more than 28 degrees away, so it's not too easy to glimpse. At the moment, it rises in the east a little before the Sun, but I think you'll be well lucky to see it. It goes around the Sun in 88 days. There was a time when we thought it spun round at the same time. If that had been so, there would have been an area in permanent daylight, an area in permanent night, with a narrow twilight zone in between. But that's not so. The rotation period is only 59 days, so every part of the surface does get sunlight at some time or other. Well, 30 years ago, a probe, Mariner 10, went past it and sent back pictures showing a rocky, mountainous crater surface looking well like that of the Moon. But now, Messenger has done far better. And to tell us about that, welcome back to one of our regular and very great friends, Dr David Rothery of the Open University. Dave, welcome back. First of all, Messenger, launched in 2004, been a long time getting there. What about Messenger?
Well, we're all very excited by the pictures that are beginning to come back now. As you say, it took 3.5 years to reach this first flyby of Mercury, and that's not the end of its journey. It has to fly past Mercury twice more before, on its fourth encounter, it's travelling at the right speed to be captured into orbit around Mercury. So
that'll be in 2011.
2011. There's another flyby later on this year, and another flyby in 2009, and then a wait until it comes back and can be eased into orbit and start a mapping mission.
Any kind of life there? I think it's absolutely out.
There's fairly intense radiation at Mercury, quite apart from the heat of the Sun. On the surface of Mercury at midday, the temperature is over 400 degrees centigrade, and if you wait long enough until nightfall, it'll get very, very cold at night, minus 150 centigrade. Mercury's not a place to look for life, but to understand planet-forming processes and how planets evolve, it's a very important part of the jigsaw.
Mercury looks superficially like the Moon, but there are differences in detail.
Yes, it's an airless body, a rocky body, lots of craters, a very old surface, and really that's where the resemblance ends. When you start looking in detail, there's so many subtle differences with them, and it's an absolutely fascinating place.
Let's look at one or two then.
Yeah. This is a view of the crescent of Mercury seen as Messenger was approaching, and the whole of this area had been seen by Mariner 10, but under different conditions. The craters along the terminator here show up very well because of the shadows. There's a crater here named Vivaldi, and if I show a narrow angle view of that same crater, here it's
a large complex thing.
It's a spectacular crater. There's a central ring of which the peaks are catching the sunlight and an outer ring. So this crater's a little bit over 100 miles across. It's one of the larger craters.
Yeah, and also these are all impact craters, and by ordinary standard they are very old.
Yes, most of these craters here would date back to 3.5, nearly 4 billion years ago, the late heavy bombardment of the solar system. But of course, cratering didn't stop. It carries on. And even the younger surfaces on Mercury, which might be 2 billion years old, still have some impact craters, but rather fewer.
Let's go back to Mariner 10 for a moment.
Yeah, well, I'll show you a Mariner 10 view of this same crater, Vivaldi. And there it is, with the sun overhead. There's that central ring.
Yes.
And there's the outer ring. And it looks very different because there are no shadows, but we're able to see the brightness features on the surface. There's a bright ray going across the surface, and another bright feature there, and those you won't see when the sun is low in the sky, so you get different information. And this is where, when Messenger gets into orbit and we'll be seeing the same features at different times of the day, we'll get a much more complete view of the subtleties of the terrain on Mercury.
People will say, why do we want to go to Mercury anyway?
Well, I like to understand my neighbourhood, and Mercury is part of the solar system where I live, and it's a sort of end member of planets. It's the smallest planet and the closest one to the Sun. It's far denser than it really ought to be.
Yes.
It appears to lack iron at its surface, and yet it's got an enormous iron core. It has a magnetic field, which it shouldn't do unless the core is somehow kept molten, which it shouldn't really be because it's such a small planet. So we need to go and understand why this is.
Yes.
And if we can understand how Mercury formed and fits into the picture, we can understand better how the Earth and Venus and Mars formed as well. It's completing the story. And also, with an astronomer's hat on, most of the exoplanets, planets that have been discovered around other stars, are orbiting very, very close to their star because they're the easiest ones to discover. So they're in the kind of environment that Mercury is today, very close to a star. So studies of Mercury will not only help us understand our own solar system, but will help us understand these rather poorly known planets of other stars that we're beginning to discover in very great numbers.
The fact that Mercury has a definite magnetic field was rather a surprise. Overall, Venus hasn't got one, and Mars very little.
Yes, I mean, one of the great triumphs of Mariner 10 was to discover this unexpected magnetic field at Mercury. It's about a thousandth the strength of the Earth's field, but that's still, for a small planet, a pretty strong field. And there's really no escaping the fact that that field has to be being generated today. It's not magnetic rocks locking it in. In the interior of Mercury, at least part of Mercury's large iron core must be fluid, and although Mercury is rotating very slowly, there's some kind of turbulent motion in this fluid, electrically conducting core, which is acting like a dynamo and generating a magnetic field. But people don't understand the details of how it's happening, and that's why all the probes going to Mercury now are carrying magnetometers to try and map out the field. And we would like to know very much, has the magnetic field changed in the 30 years since it was first measured by Mariner 10? Because the stability of the magnetic field is a big question. It could be strengthening, it could be weakening, it could be changing its orientation.
Let's have some more detailed review, shall we?
Yeah. Well,
Caloris.
This is the Caloris Basin, which was seen by Mariner 10, and here's the terminator. So it was sunset along this line, and we see half of a very large impact basin that's almost 1,000 miles across. And that was, we're very much looking forward to seeing this in Messenger. And here's the view that Messenger saw of Mercury after it had flown by. And the Caloris Basin is up here. It's under full sunlight. It's rather like that Vivaldi crater situation in reverse. It's just a bright feature with a dark halo around it, and very few topographic details showing up. So Mariner 10 gave us a better view of Caloris, or at least a different view of Caloris than what Messenger does. But put the two together, we have a more complete picture. What we can see now inside the basin, these small dark blobs are craters with dark halos around them. Nobody understands those.
No, I don't know why.
And there are various bright spots there, which appear to be the youngest craters on the planet. Younger craters have bright ejecta blankets, sometimes bright rays, and as they age, as they're subjected to weathering in space, they get darker and the colour changes as well.
You see one ray crater there?
There's a very prominent ray crater over here near the terminator.
Yes, that's what I mean.
There are others elsewhere as well. There are a phenomenon very well known on the moon. Tycho near full moon has wonderful rays. Copernicus has rays. What struck me when I first saw this picture was not so much the cratering, because I'm a volcanologist. I saw the blotchy area in the north here, and now we have a narrow angle camera view of that. That's towards the North Pole.
It looks far more lunar, of course.
It begins to look lunar as you get in to see details like this. There are some traces of craters which appear to have been flooded. These are very young craters superimposed on it, but this whole plain area here, it's the closest thing we have to the lunar maria, which are flooded by basalt lava flows. We don't get such high mountains thrown up as a result of impacts on Mercury. It's got stronger gravity. It's about twice the strength of gravity on Mercury as on the Moon, because it's a denser, larger body. But I think this kind of area on Mercury has been flooded by lava flows.
It must have been, surely. What else can it have been?
It could be covered by fragmentary ejecta from giant impacts that can plaster the terrain. That's the competing theory. I don't think it's right. I think it's lava flows.
It's lava, certainly.
And that's very important. If you have lava flows on a planet, it gives you a real key to look inside the planet.
One thing strikes me, I mean, we know Mercury has a large iron core, probably larger than the entire body of the Moon. What about the decomposition of the crust? Is that rich in iron?
Well, this is why Messenger has gone to Mercury, and why Europe is sending a mission to Mercury called Bepi Colombo in a few years' time. Mercury, very large iron core, as you say. It must be iron. It's got a very large core.
And a magnetic
field. Yeah. So we're thinking iron core. But the surface of Mercury, so far as we can tell from telescopic observations from the Earth, is very deficient in iron. If there are minerals containing iron, they will show up in the spectrum, and they barely register at all. So it seems that Mercury's crust has no iron bonded to oxygen, at least. And we will find out why that is from MESSENGER, because it'll be trying to map the mineralogy.
Well, one theory, wasn't it, that in the early days, Mercury was struck by a giant impactor, and the crust was stripped off, leaving into the core.
Yes, exactly. But every planet has suffered giant impacts as it was forming. It's inevitable. It's part of the planetary growth process. And the body that's now called Mercury could have been a little bit bigger at one point, was hit by something, it stripped away the rocky crust and mantle, and what we see now is just a sad remnant of the outer rocky part. That's one theory.
Do you agree or not?
I think it's an attractive theory, and when we have got some more data from MESSENGER and the European Bepi Colombo mission, then we'll be able to make our minds up. But it's certainly one of the theories that we're going to test.
Let's go to some more areas, shall we?
Yeah. Here's the outbound view again. I want to show you a region around here. There's an impact crater here with a rather intriguing feature across it. Top left of the view is the rim of the crater, and coming across the crater floor there's a cliff. Well, it's not quite as steep as a cliff,
no.
But this is a feature known as a low-bait scarp. We saw many of these with Mariner 10. And they've all been named after ships, for Captain Cook's ships, Discovery and Endeavour and so on.
Well, what about beagle rupee? That was your idea.
I would love, these are called rupees, that's the word for scarp. I would love for this one, or one of the many others, to be called beagle rupees.
Yes,
There's none of these scarps on Mercury yet been named after the ship that Darwin sailed on to discover the evidence behind the theory of evolution. It's nearly 150 years since The Origin of Species was published. Beagle rupees would be great for that. But leaving the name aside, this is a tectonic feature. It's fairly clear that this whole family of scarps we have on Mercury are when the crust has been buckled and one part has been thrust over a neighbouring part, and it appears that the whole globe of Mercury contracted by only a fraction of a percent a long time ago, 3.5 billion years ago. As Mercury cooled, it contracted, and the surface wrinkled like the skin of a dried apple, perhaps. But that's a feature recorded in that episode of Global Contraction, and you can tell it's a long time ago. This impact crater here is formed on top of it. So there's a big old crater there with the escarpment cutting across it, and a younger crater there on top of the escarpment. So you can piece together a sequence of events. I have a slightly broader view, again from the narrow-angle camera. I mean, it was a little further away, and here's the area that we were looking at.
Yes.
And if we go closer into this area that's now in the middle of the screen, a closer-up view, this is about the most detailed view I've got to show you, Patrick. The smallest impact pits here are only a few hundred metres across.
It's amazing, isn't
Here's another of these compressional escarpments. Call that one Beagle rupees if you like. I don't mind where the name gets given. But there's a ridge here.
A wrinkle ridge?
Exactly. I think that's what we'd call a wrinkle ridge if we saw it on the moon. That's not a tectonic feature involving faulting in the crust. That's what happens when lava flows are in place, and then they cool a little bit, the surface gets wrinkled up. And you can see these in lava lakes in Hawaii and so on.
See, on the moon, the Mars Trinitatis.
Yeah, that's a very good area for them. And many places on the moon which are flooded by lava have these wrinkle ridges. So I think the wrinkle ridge appearance is more good evidence that we have areas flooded by lava. That's lava, not a thick blanket of impact ejecta covering that part of the surface. Then the cratering on Mercury is...
South Pole here?
That's the South Polar region, and to me that looks very lunar, and you're the expert on moon craters. Does that look like the moon to you?
It looks very much like the moon. Yep. I didn't know, so it could be the moon very easily.
And there are very conventional looking craters here, the craters which are 50 miles or so across have central peaks, very like on the moon, but there's an actual line, 1, 2, 3, 4 craters there in a dead straight line, but all look to be the same age, and I'm just wondering how that formed. 4 in a line is a little much for coincidence. There are chains of craters on Jupiter's satellites Callisto and Ganymede, which appear to have been formed when a comet swung past Jupiter and was tidally ripped apart and then happened to hit the satellite on the way out, and the fragments hitting one after another, it was a bit like a hail of machine gun bullets, bam, bam, bam. I'm wondering if this is a comet that went round the sun, got ripped apart by tides, then hit boom, 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 four fragments. We'll be looking for more crater chains like this on Mercury to see whether it's a common phenomenon or not. And this crater in the centre here, 30, 40 mile diameter crater, there's the crater rim, perfectly ordinary crater, and this in the middle looks like a ridge, but it's not. It's a dip. The sunlight is coming from the top right. There's a depression on the crater floor shaped like a letter C. This has been described to me as looking like a copyright symbol. But how do you get a depression on the crater floor? It's not part of a crater forming process. It must have collapsed later. Now, how do you make an area collapse?
I don't know.
It has to be undermined by something. Is there some volatile substance percolating the regolith on Mercury? We don't know yet, but if depressions on crater floors like that are more common, we'll have to think.
There's another shade down the lower right-hand side. Looks the same to me.
There's a small, curiously shaped depression down inside a rather poorly formed crater. Yeah. So yeah, maybe there's a theme emerging here that there are volatiles on Mercury, but when they disperse, they leave a void and some collapse occurs.
One point I think people are going to ask, and we know the answer. I mean, there's virtually no activity on Mercury now.
It would be very surprising to find anything going on Mercury. It's everywhere looks very old to judge from the number of craters, but it doesn't mean there are no processes happening at all. Mercury has a very, very thin atmosphere. It's sometimes called an exosphere. Yes. There's sodium and a few other elements detected in space around Mercury. And as micrometeorites hit the surface, they do vaporise some material, and there's a little bit of a sodium cloud and some potassium and some calcium. This is a pretty much natural colour view of Mercury as Messenger receded.
It's what you see if you were there.
It's what you would see if you were there, if your eyes could see a little bit further into the infrared than they can, but true blue is blue. Just imagine your eyes being a little bit more sensitive across a wider part of the spectrum. It would look like this, not very colourful.
And there's a bit of blue there.
There's a little bit of blue, there's a little impact crater there, a young crater which is blue, but it's very easy to enhance the colour, not to make it artificial, just to make the colour show out by tweaking the saturation. And here is the same view with the colour boosted on it. And the feature that you spotted that was blue, Patrick, is very clearly blue, and there's some bright blue features up there.
And what does this tell you about the composition?
Well, it's confirming what we thought we knew already, which is that as Mercury's surface ages, it does get more red. Now, the reddening is probably due to micrometeorite bombardment affecting the surface, and you get small amounts of glass formed by melting the rocks during impact, and maybe the release of iron as tiny particles of metallic iron, and that will contribute to the reddening of the surface. So the blue areas tend to be younger, and that's confirmed. We would think that was a young crater there because it looks it and boosts the colour and it shows up blue.
What other instrument does Messenger carry?
Well, one thing it has is a gamma-ray neutron spectrometer, and this can measure natural radioactivity and find things like uranium, thorium and potassium, but also the neutron part of it is curiously designed to look for ice. There was an instrument called Lunar Prospector, which around the moon found indications of ice in lunar craters. Not ice rinks, not a big sheet of ice on the crater floor, but just ice mixed in with the regolith. The idea is if you can find that the flux of neutrons is affected differently over the poles than it is over the rest of the globe, you're relating it to hydrogen, because the neutrons are slowed down when they bump into hydrogen atoms, and the only thing hydrogen can visibly sit in is water ice. So if you find this dip in the thermal neutron spectrum over the poles of Mercury, it'll indicate hey, there could well be water there. The reason we're going is to test, to try and find out. I know you don't believe in ice, but some of these craters are formed by comets hitting the planet, and comets are made of ice. So there's a delivery mechanism of ice to Mercury, which is going on today. So some of it could be trapped.
Imagine the heat generated.
Yeah, most of it is vaporised and lost, but some of it will come back to the surface because of the gravity. So, but it has to be tested. But the way I think most scientists would look at it is that there's a strange signal we have to try and understand. Yes. So let's go and test it. We've just designed an experiment. One of the experiments is look at the neutrons. Does the neutron data confirm or refute the hypothesis that there's ice in these craters?
I wouldn't call it that. One thing strikes me, Mariner imaged about 40% of the surface, and Messenger added another 25 or so. There's still a part we haven't seen.
Oh yes, well we have 2 more flybys by Messenger, which won't extend the unseen part very much farther actually. We won't see the rest of the globe properly until we get into orbit. There's bound to be something really striking in the missing bit, so I'm waiting to see that filled in.
Well, come back and tell us about it. Dave, thank you very much.
Thank you.
Well, on the 21st of February we have a total lunar eclipse in the early hours of the morning, so do stay up and watch it. It's a very special one. There won't be another till the end of 2010. Well, we had one last year, and of course we covered that, and we all enjoyed ourselves. Chris with me, and also a number of astronomers, both professional and amateur.
It's March 2007, and we have an eclipse at a civilised time, the right side of midnight, which has brought many astronomers to Patrick's Garden. The last eclipse visible from the UK was in 2004, when it mostly rained. So everyone's keen to take advantage of tonight's crystal clear skies. Brian May's here with a new telescope to try out, and so too is keen astronomer John Culshaw. So are you just an eclipse astronomer, John, or is this something you do
No, as often as possible. I got these binoculars. They're about 60 times magnification. I got these back in about 1991. At the time I used to do a late night radio show and would often drive home when the moon was setting, and it was that deep orange colour in the sky as it was just about to set.
Almost as if it was eclipse.
Yes, or as though it was Mars, something like that. It really gets your imagination going. I'll always get up at 4 in the morning, whenever they happen. I always want to go and have a look.
When was the last lunar eclipse you watched?
The last good one, I think, was many years ago in the 80s when I was in Marbella with the kids, and it just happened to be a good spot and it was a perfect sky, and we stayed up till about 4 in the morning and there it was, perfect, lovely blood orange in the sky.
Solar eclipses happen quickly and cause panic, but lunar eclipses are more relaxed affairs, lasting for hours. As the moon creeps behind the Earth, a shadow is cast across its surface in what's known as the penumbral phase. Once the moon fully enters the Earth's shadow, the umbra, it should be completely dark. But light is refracted or bent through the atmosphere of the Earth, illuminating the moon even in the middle of totality. Well, here's the image, Pete, and look, I think... And yes, you can see it with the eye. First contact, don't you think?
Yeah, definitely.
So first contact, the proper eclipse has begun.
It has.
So the next question is, what's totality going to be like?
I reckon it's going to be dark. The difference is you can get very light totality when the moon is a coppery, very light coppery colour, sometimes with blue edges around it, or a very dark totality where the moon actually disappears. You can hardly see it in the sky. And the difference is, if you can imagine what's happening, the light is coming past the Earth and it's being bent as it goes through the Earth's atmosphere. But the blue light scatters, so only the red goes straight through. So the red light actually infills, if you like, that dark shadow in the middle.
Hits the moon and bounces back to us, so we do get sunlight from the eclipse.
That's right, we just get the red light, which is refracted through our atmosphere. But the darkness of the totality depends on what's happening in the atmosphere. If there's lots of cloud and gunk in there which stops the red light getting through, then it's a dark totality.
Well, John, what do you think so far?
I'm surprised by how sharp the line of that shadow is.
It's almost like a solar eclipse.
It is.
It's very, very sharp.
It's so defined. And we're starting to see the colours now. That redness is starting to come through.
And you can see really clearly now the bottom of the moon where there's the chunk cut out of it. You can see that it's glowing with light reflected off the surface and back to us.
Just under halfway there now, so it seems. But even though, you know, we've seen a few lunar eclipses before, but every one of them is different from the last.
And for me, watching something change in the sky, this wouldn't happen last night, it's not going to happen tomorrow, it's not going to happen for another year. No. It's nice to be here.
It's wonderful.
It really is.
A total lunar eclipse only happens when the Earth, Moon and Sun form a line, with the Moon on the opposite side of the Earth from the Sun. You might therefore expect an eclipse every month, but the angle of the Moon's orbit means it only happens at most twice a year. Even then, it can be years between eclipses which are conveniently visible from the UK.
We're very nearly at totality now. We can still see the entire moon, but it's a lovely eclipse, this curious rose-pink colour, something I've not seen before. What do you make of it, Brian?
Very different from what I've seen before. I thought the actual line of the shadow was rather sharper than I'd seen before, and it's this wonderful pinkish grey colour. You keep wondering what it would be like to be standing on the moon at this moment, don't you, and what the Earth would look like, because nobody's actually photographed that, have they?
No, but you get this ring of fire around the Earth, a bit like an annular eclipse, I suppose.
Must be wonderful to see.
I was wrong when I said it was going to be a very light eclipse. It's not.
No, but it is unusual. And I think colour-wise, it's certainly not a deep blood red, which you sometimes get.
And then one thing, it hasn't got the drama of an eclipse of the sun, but an eclipse of the moon has got a quiet beauty all its own.
Absolutely. It looks incredibly three-dimensional, doesn't it? It looks like a ball.
Yes, I wonder
disc.
why it has that effect.
I think it's because it looks like it's being illuminated from the side, which is not, of course, but it looks like that, doesn't it? It looks like it's got a shiny edge to it.
Yes. It's almost as if it's jumping out of the sky at you, doesn't it?
It's not like any eclipse I've seen before, and I've seen plenty.
I think it might be my favourite lunar eclipse ever.
Excellent. Roll on the next one.
Yeah.
You know, you just see it, and you go all sort of sexy about it, don't you? Because it's wonderful.
Lunar eclipses are slow, subtle, beautiful things, and tonight has been no exception. When you look at the pale orange moon hanging among the stars of Leo, you know you'll remember that for a long, long time to come.
Well, that was last year's eclipse, a very special affair. On February 21st we have another, and I'm sure it's really worth watching. It begins about 1:40 and is total from 1 minute past 3 to 3:50. It means staying up late, I know, but believe me, it's well worth it. And now on to our news notes. So, of course, asteroid 2007 TU-24, quite a big near-Earth asteroid, and whizzed by it 1.5 times the distance of the moon.
Yes, it passed by just a couple of days ago. There was no danger to us, but it was bright in the sky, about magnitude 10, so big binoculars would have shown it. And there's some nice images.
And 800 feet across. So had that hit it, it would cause global devastation. But
yes.
Let's say there was no chance of that.
Nope, it whizzed on by. It was only discovered in October, though, which shows how bad we are at spotting these things. Really, to only have had 2 months' notice of such a close approach, if it had been on target to hit, say, here in Selsey, there'd be nothing we could do about it.
Not a thing. Now, let's go on now through to Mars, shall we? And the Spirit rover.
I've got some good news. This is Spirit's current location. This is home plate. Yes. And if you remember, Spirit was heading to the north side of this, where it could point its solar panels towards the sun, because it's entering winter in its hemisphere of Mars, and it needs all the power it can get to survive. And the good news is it's got there in plenty of time, and it's now sitting tight, hoping to survive the cold Martian winter.
What about Bigfoot?
Oh, yes. Yes, this is a re-release of a slightly older image.
It's great fun.
Yes, as you can see, in this image, there's clearly what people have interpreted as either a human figure or, I believe, the Little Mermaid. And
it's a rock with shadows in the background.
It's clearly a rock. The images were taken several hours apart, so if it is a creature, if it was a creature, well, we know it moves very slowly.
But certainly both these probes are doing very, very well.
Yes, and don't forget we've got our fleet of orbiting spacecraft as well. Look at this from Mars Express. This is Turby Crater, and it's a place where water has shaped the landscape. Look, there are channels coming down here, These are large outcrops called mesas, like you see in the desert, where water's flown in between.
That must have been water, can't have been anything else.
Absolutely. So it's an important region of Mars, and it illustrates why we need different spacecraft. From Mars Express, we get a wide view and we get a stereo view, a 3D view. But you'd like to, as geologists, would like to get a close look at the layering at the end of these outcrops here. So if we switch over to Mars Reconnaissance Orbiter, the colour scheme is slightly different, but this is the same region, and you can see this dark region overlying lighter material underneath. And there's enough in these pictures to keep a single geologist happy for years trying to understand what's happened to this area.
There certainly is.
And here's another of my recent favourites.
Oh, dust devils.
That's right. We've seen dust devils from the rovers. There are amazing images, movies in fact, seeing these things whipping across the plains. Here you see the tracks they leave behind. This is a dark region with bright dust on top. And when a dust devil, a little tornado goes across, then it clears the bright areas and you leave these trails behind.
Well, Mars has plenty to tell us, so let's go further out now to Jupiter. Interesting things happening there.
Yes, some nice results from the Hubble Space Telescope. Here's Hubble's view of Jupiter.
Oh, yes.
Scientists have been studying in particular the storms in this region up here. We want to know what the source of those storms are. Remember, even these tiny ones are the size of a continent. So they're large features.
And they're certainly deep-seated.
They are. If you look in the infrared, you can see the jets from the storms very well. The winds here are several hundred miles an hour, so they're huge events. And it turns out they start low down in Jupiter's atmosphere and then bubble up high above what we see as the visible surface. So by combining the infrared and the visible, we can get a sense of how these things evolve.
Let's turn now to the most important body in the solar system, which is our own sun. We have the start of the new solar cycle and the picture of the first sunspot of it.
Yes, here it is. The picture's in the ultraviolet from the SOHO satellite, and this is it. The sun has peaks in activity roughly every 11 years or so, and we've just entered the new solar cycle. It's the 24th recorded, and we're heading now towards a solar maximum, a peak in activity, which is due sometime in 2012.
I wonder how energetic it's going to be.
Well, the last one had this strange double peak.
Yes, it did.
The prediction for 2012, I think, is that it will be relatively quiet for a maximum, but it's much less accurate than weather forecasting. It's a difficult thing to
With the sun, one never knows.
Precisely.
Now let's go up beyond the solar system, shall we?
Yep, let's do that, and let's start out here. Well, in fact, let's start the centre of our galaxy.
Yes.
This is a new image from the United Kingdom Infrared Telescope, and it's been surveying the sky, and the first results are now out. So this is the galactic centre in the infrared, or you can look at star formation. Yeah. And here is a recently formed massive star, what we call a H2 region, with the remnants of the material from which it forms scattered around it. It's absolutely stunning, and all of this data is now freely available on the web for any astronomer who wants to use it. What about looking at things you can't see? This is a result from Hubble. This is what's called the Stages Survey. This is a giant cluster of galaxies, Able 901 and 902. And what you can see in pink is a reconstruction of where the matter is. Most of the stuff in this galaxy cluster is actually dark matter, not atoms that make up you and I, but dark matter, a mysterious substance that dominates the universe.
What is dark matter?
We don't know. So all we can do at present is to see how it behaves. We know where the dark matter is because we see it distorting the light from background galaxies. And just occasionally this can create spectacular effects. So you be the observer. Now imagine you've got a galaxy here, say we'll have this one 3 billion light years from you, and then one here 6 billion light years. And if they line up exactly, the light from this one will be bent by the nearby galaxy on its way to you.
Einstein ring.
Exactly, you get a ring around the galaxy. Now, if you're really lucky, and the odds are about 1 in 10,000, you might have another galaxy all the way back there, 11 billion light years from you. They all might line up, and then you get a double Einstein ring, which is what astronomers found in the Sloan survey. And this is the first example of this that we've seen. So we've got a nearby galaxy, an inner ring, and then an outer ring as well.
When you say nearby, how near?
Oh, well, the most distant galaxy is 11 billion light years away, and that's why this is important, because not only do the images get distorted, but they get magnified as well. So we see distant galaxies that otherwise we'd have no hope of seeing, at least with a short exposure like this. So we can think of it as nature's telescope to see these distant galaxies.
Well, we never lack news notes. Something new is happening almost every day now.
Yes, and you always get stunning images like this along the way as well.
Chris, thank you very much. Next month, a very special programme. An hour-long programme for BBC4, and we're going back to the moon. Until then, good night.